Okay. And does that answer your question? Okay, great. Anyone else with any other doubts? So, how are we all placed on the assignment front? We have completed 8 sessions today. So, we are definitely running one session behind. Ideally, today should have been the last one of uh, pandas, but we are on the second last. So, we have 9 and 10 left. We are in a way we are one session behind. This is our week 11. First session was the introduction, and then there was supposed to be 10 more. So uh, we are going to cover a few important topics, but just before we kind of get into it full on, I wanted to check with you all. Okay, you are okay on week 5. How about others? Question number 2. Okay, Aruna's question. Oh, that's great, Jasmita. So 7 and 8 is the visualization. Great. That is a relatively smaller assignment. You won't have a problem with that. Okay. Who's going to help Aruna? We'll do this question and then we'll move to today's topics because we are already good 10 minutes into the session. So let's not spend too much time. But at the same time, yeah, I don't mind. We can finish off this one. Which bowler bowled maximum number of overs? Okay. There is no filtering needed on the basis of the team. We are talking about the overall. So what would you do? So Aruna, how did you approach this? And where are you stuck? It's not very clear. Uh, how about others? Is everyone having a problem? Even you are not able to hear properly? Okay. Um, so who is Jai Krishna's? Okay. Yeah, you can quickly reconnect, Jai Krishna. We'll finish off this question. So I'll wait for you. Okay. Who's are you using? Actually, I see that most of you are on web. Interestingly, the app works way better. I'm sorry. The balls of each over is 6 and 7. I don't get what are you saying. How will you start? Mm-hmm. Yeah. So when you do group by bowler and count on the ball, it will give total number of balls the bowler has bowled. Right. We can divide it by 6 to get us a vague kind of an answer on the yeah. So which is fine, which is a valid. So let me do that first. So let's say this is a definitely an easier approach. So we say group by bowlers and dot count. So I'm just counting the number of rows. Sorry. Mm, did I make any spelling mistake? Bowl. What am I doing? Acha, it's bowler. Simple count will work. Okay. And then and what is the question? So I can say the largest one. So, okay, because we are doing the count on, so it doesn't matter any. Let me just say pick a column to make it easy. And largest will give me this, and then divide by 6 will give me the answer. Okay, this is one approach. It will give kind of a broad, uh, it won't be a very precise answer, but it's a fair approach at the same time. Second approach, what can you do? So there are unique match IDs and the innings. So we can do the grouping at a finer level. So what we can say is that I want to okay, so we have the bowler. What approach can we use is for each match ID, for each match ID and each bowler, over there is a how many unique rows are there. Okay, data frame object is not callable. So we are saying over dot n unique. This also does not give me. I should have got the n unique. Sorry. Okay, let me. Yes, no, over some. What are you doing? Over is an integer column, so you cannot sum the over. Do you get that, Akshit? I want to find the unique over numbers and then sum it for each and every match ID. That is my approach. I can take a look at this part of the code. I'll keep this open so that I can come back to it at the end of the class or something. But broadly, we can use this approach to find exact number of unique, overs for each bowler and for each match ID. And we have to group by match ID as well, because otherwise what will happen? We will there will be duplication here. So we cannot find the unique for over number. So that is the approach. So let me see what part of the code is breaking. The ball is correct. So it is saying that the data frame object is not callable. I'll have to check what exactly is the issue here. But broadly, this would be the approach. I'll just come back with a exact code. I'll have to just try out a couple of things and then see. In fact, let me just. So, Jai Krishna, okay, you're back, right? You're able to hear? I can count the unique instance of each over number, right? For each match, the over number, uh, how many unique over numbers are assigned to a bowler, that would give me the count. So I just want to find the unique over numbers per match per bowler. And then I have to find the sum of all of them for each bowler. So this becomes like a two-step. It's a slightly complicated code, but it gives you the precise answer. But otherwise, for practical purposes, oh, okay. So for all practical purposes, getting the number and then dividing by 6 is fine. I'll just come back with this part of the code. Okay, so we will start. I was waiting for Jai Krishna to join back in, and I'll come back on that particular question at the end of the class. So now we are going to look at a few advanced topics. Merge, basically working with multiple data frames. That is one absolutely important and necessary skill that you need to work with, because very, very often you're going to have to work with multiple data. Even in your organization, many times it happens that you're having, like those who have worked with data in SQL, right? I mean, you have multiple tables and you're trying to join. So as you know, even in SQL, join is a very important concept. So similarly, the same thing applies here. So there are various kinds of merging and joining and concatenation that we're going to talk about. After that, so merge is a fairly large topic. Second is the reshaping. I introduced pivot in one of the earlier sessions. We'll talk about it in more details. So pivot and melt. So both are a part of, they are essentially the same thing, just opposites. So, and then there are couple of other important, not very important, but a couple of other functions which are used primarily from the machine learning point of view. So you'll be making use of them. I remember somebody asking about cross tabulation. So this is when we talk about that. And then we move on to the string methods. So as I was saying, when you are working on a data, it's not that you need to apply all of your skills all the time, but there are a few key skills. So one is, of course, managing time. So if you're dealing with data which is heavily time related, then your date time, that whole topic that we covered, the whole session, that becomes very important. Another very common kind of a data set is, a pure text data, your sentiment analysis, the text mining. So in that case, most likely your data would be more like, just some, say, you want to find the sentiments of the reviews of a particular product on Amazon. Now you have, say, 10,000 reviews, or in fact the project that you're going to work on at the end of our 15 sessions is the sentiment analysis of the IMDb data set. So there are so many movies, right? And then there is the feedback or the review of that movie in the text format. Now trying to gauge the sentiment out of it, so the positive words, the negative words, and the customizing, so that all comes under. So this, of course, the text data analysis, this part is, we're going to just talk about the manipulating and standardizing your data frame. And then the sentiment analysis part, of course, we'll cover when we come to machine learning. We'll also introduce regex. So when if we come to this, most likely we'll cover the text part in the next session. And then this is all a part of the text. It's a fairly large topic. And then this is actually the last session, which talks about some miscellaneous topics. So let's get started with that. So so there are multiple ways you may be combining data set, as I said. So primarily there are multiple functions and there is a slight overlap. So what I have done is that I've made it a little more concise so that it doesn't become very complicated. Unfortunately, so for example, joining data. Uh, uh, does anyone remember how do you join NumPy arrays. We talked about that in when we were in the NumPy topic. If you have two NumPy arrays and you want to combine them, you want to join them horizontally or vertically, how would you do that? Yes, so either you concatenate or so I have A1 and I have A2. If I want to combine the elements, want them one on the top of other, what would I do? As Deepak said, concatenate and then it has a, so this has just combined the elements and it has become, it has created one NumPy array. And how do I stack them? So of course, this is one method, and we also talked about one more thing. So the access. This is surprising. This should have concatenated at, so we have our array A and array B, and then when I concatenate, okay, let's hold this. So there is another function that we talked about, that was horizontal and vertical stack, correct? So we can use np dot v stack in this case, and we can say a1 comma a2. This is something I commonly use and remember. So now with this reference, let's go to these three data frames. So we have data frame D1. You can see the column names are A, B, C, D, and we have values nicely aligned, A0, A1, A2, A3, and so on. And then our indices are also in this particular order. So we have indices here from 0, 1, 2, 3. And for DF2, the indices, they are not starting from 0, but they are starting from 4. And then DF3 are starting from 8. So you can see that the data is very neatly aligned on top of each other. What we can use is that, as I said, when we talked about concatenate in NumPy, that for pandas, the function is called concat. It takes a list as an argument. So this is something to remember. It takes list of data frames. If you try to pass simply the names of the data frame to concat or a tuple, it will not work. So you have to pass a list. What it does is that by default, it will just concatenate or rather append the rows, one below the other. So this is the default behavior. This is how it would work. And you can see, we will see what happens if the indices are overlapping. But this is the very basic simple example, right? I mean, as we've been doing with so far, that we start with a very, very simple example and then we introduce uh, problems, difficulties. So this is our concatenate at the very basic. So we have, like we saw the axis argument in NumPy, there is an axis argument for pandas. The default axis is 0. So if you don't specify axis, it's going to assume that it's on axis 0. We all know by now that 0 will work row wise and 1 works column wise. So when the default axis 0 is being applied, the rows are getting, appended. If I work, or if I say that I want the concatenation to happen on axis 1, what's going to happen? Now the data frames are getting appended in this order. So we are getting the duplicate columns are getting created, and because our indices are not the same. So here in this case, if our indices were the same for all the 3 data frames 0, 1, 2, 3, what would have happened? I would have just got all the rows aligned, right next to each other. But because our indices not are not same, they are unique indices for each 3 data frame. This is the kind of the structure that we are getting. So of course it's something uh, which is not relevant in this case. So as you can see, this is something that is going to entirely depend on the kind of data that you have. So the use of particularly the axis argument, it's completely going to depend on what indices are you working on. So let me now create those 3 data frames once again without the index argument. What will happen if I get rid of this index specification? Anyone? So now I have 3 data frames once again, and I have not used the index argument. So let me see the df1. That was as expected. df2, everything else remains the same. So our data is the same, column names are same, but as you can see now the indices are once again starting from the default, right? Unless you specify, unless you make use of the index argument, the indices are going to be from 0 to the total number of rows minus 1. Similarly, TF3 is also the indices are 0, 1, 2, 3. Now if I concatenate this without the axis argument, what's going to happen? I'm getting my rows appended, but my indices are duplicated. So ideally I would have to reset index to take care of duplicate indices. Usually having duplicate indices as well as duplicate columns is not advisable in your data frame because it can create confusion. So we can always reset the index and then drop this particular column that got created. Okay. Uh, Now what will happen if I use the axis argument 1 on this particular. So earlier what happened when we used the axis 1, because our indices for all the 3 data frame were different, a lot of nan got created, and the data frame they got generated in this particular order. Here, because all the 3 have the same indices, of course we still have duplicated columns, and ideally we should take care of it using rename or whatever. But this is how the data literally is kind of vertically aligned next to each other. So I have my first data frame, then second, and then the third. So this is how concat works. Is this clear? This is a very simple example. In fact, this is the example I've used from the documentation of pandas. I think I have also given the documentation link. Yes, it's a fairly exhaustive document. So this is our concat at the very basic. So now I have created another dummy data set. Let's say I have this data frame called student, which is the name of the student and the student ID. And I have another data frame called marks, which is just the subject marks. Of course, ideally you would never have these kind of data frame and you would not be expected to combine them. Why? Because in this case, what is happening is that we just have one data which is name and ID, and the second which has two subjects. We don't know how which row corresponds to the name and ID in my student data frame. So ideally, this would not be the case. Like we've seen, those who have some exposure to SQL would also know that typically when you're working with multiple tables, you would have a key, one common ID column, right? I mean, which one common column which would work as the connection. But let's say, just for the sake of theory, we have two data frames. Number of columns really are, so both have two columns and three rows. So exactly in a way it is aligning, and even the indices are the same, 0, 1, 2, 3, 0, 1 and 2. If I use concat, what happens is that this is the kind of data I get. So my rows are getting aligned. Now, as I was saying, there's also another function called append. Now, don't ask me why there are multiple functions doing the same job, but yes, so we do have append. But in principle, what I do personally is that for vertically or horizontally stacking the data frames, I strictly always use concat with the axis argument, so axis 0 and axis 1. And for merging using a key column, or there could be multiple key columns, I use merge. So for even for merge, there are two different functions, but I just strictly stick to that. So this is the use case at the very simple. Of course, we will talk about overall merge in a little more detail. But this example was just to show that how you can combine multiple data frames. Now let's go back to that same example. I have recreated, as you can see, the data frame. So now I have, now this data is a little more meaningful. So I have the marks column, which looks like this, and student. So now, as you can see, there is one ID column which is common for both the data frame. So this tells me that, okay, there is some connection between the two data. So this is the identifier. This is the common column. So now it becomes easy for me to uh, try link the name to the subject, right? Which was not really happening in the case of concat. So this becomes more intelligent join. It's trying to see where the values are. There are common values, and then it does the merging on that. So what is the syntax for merge? It takes the data frames. So in case of concat, please remember it takes a list as an argument, right? We have to pass the list of data frames. As you can see here, I'm passing the list of the two data frames, student and marks. Here, you just simply pass the data frames. The key the important parameter in case of merge is the on. That means what is the column on which you want the merge to happen. So what is your identifier column? In this case, clearly it is the ID. We have this ID column in both the data frames, and I want the data frames to merge in such a way that the IDs align nicely with each other, right? So let's say I So this is my syntax, pd.merge student marks and on is equal to id. What happened? I got only 3 rows here. So can someone tell me why? I do have 4 rows in the marks and 4 rows in student. Yes, so there is one instance where the IDs are not matching. So it could find ID 1 in both the cases. So it did the relevant merge. Similarly, 2 and 3. And it could not find, so there is an ID 4 here and ID 5 here. But yes, Ash. So this is a default as I've written here. The default join is inner. So it's only going to merge where it can find the ID for both the data frame. And this is my inner join. And we'll also look at. So now I'm once again, I have created the student, and now what am I doing? So there are 4 different uh, kind of joins that you can use. One is the if you don't use the to specify the kind of the join, the parameter name is how. So as you can see earlier, I just introduced the first parameter, which is on. That means the column on which you want the merge to happen. Now I'm introducing the second parameter called how. Why I didn't have to use the how in this case? Because the default is inner. So I don't have to specify how is equal to inner, because it's just going to assume it's the inner join. But if I want it to be something other than inner, then I have to make use of the parameter how. Now I want to do a left join. What will happen in the left join? So I'm saying pd.merge student comma marks. So this is my student name and ID, and my IDs are 1, 2, 3, and 5, not 4. And then I have marks. So my student is the left data frame, marks is the right data frame. When I say left join, it keeps all the rows of the left data frame, which is student in this case. So all these 4, Alan, Jack, Sparrow, and New, 1, 2, 3, and 5, that remained same, but it only picked up the corresponding IDs from the right data frame, which is the marks. And in this case, at ID number 5, there is no data available in marks. What it did, it introduced some missing values, the nan. So it automatically introduces missing value where it cannot find the common data points. So this is the left join. Similarly, you could also use right join, in which case it will be exact opposite. It will keep all the rows of the right data frame. So I can just simply do it here to show you. All I'm going to do is change the how parameter, and what happens? Now my math and science, there is no nan, and my IDs are also 1, 2, 3, and 4, because those are the IDs in marks data frame 1, 2, 3, and 4. And it got the values, corresponding values in for 1, 2, and 3 in the student data frame, but it could not find ID 4 in student. So you can see a nan here. So this is how the left and the right join work. And of course, the outer join, what would it do? It will just get all the rows from both the data frames. So now I have IDs 1, 2, 3, 4, and 5. And what is happening? Wherever it cannot find the relevant values, we got a nan here, here, and here. So wherever we saw earlier, right, there were missing values, it got the nan. So are we clear up to this point? The inherent difference between concat and merge. So that's the reason I use the same data frame here for concat. So concat, what was happening was we were just simply pasting the data next to each other. In fact, I can also try to show you the concat here so that it becomes a little more clear. So if I use student and marks, and of course access 1, what will happen? You can see the ID is duplicated. Concat literally just pastes, data frames next to each other or one below the other, depending on the access parameter. it does not use any intelligence. So you can see that even the ID numbers are not matching, it doesn't care. As long as the indices are matching, and in the case of access 0, what will it see? It will only see if the column names are matching. So if I make this access 0, it will just match the ID. Rest of the columns are not names are not matching, so it just introduced a bunch of nan. So concat is in a way a slightly less intelligent join, you can call it that. It just pastes the data frame, but of course it has its own utility. Let's say you are getting the same data, you're getting the dump every week or every day. It could be your sales data, it could be stocks data. Then your say, let's say it's the stock data, and you just need to update your database with uh, the new rows which are coming in every day. Of course, the columns are the same. It's exactly the same kind of a data. Then what you need is you just need to append, right? You just need to concat the remaining rows, the new rows with the existing data frame. So concat has its own utility. Merge, of course, is more the joins that you would have seen in SQL. So it's exactly the same concept. So are we good up to this point? These are two very important functions that we have covered now, and overall very important topics. Okay, great. So now, of course, merge. We are still on merge. We are not done. Once again, we have now we have another data frame. So let's see how do they look like. So we have a DF1 called. It has two columns: batsman and team. And there is the name of the batsman and the name of the team, and it has three rows. We have a DF2 which has interestingly four rows. It has once again a team name, so we do have a common column, as you can see. And now we have a bowler name, so name of the bowler. And you can also see that here in DF2, the first team name is RCB, then TD, then MI. In DF1, we had the first team was KKR, then RCB, then DT. So even the order is not same. So let's see how do we manage that. Of course, you know that if I use concat on it, what will happen? It will just simply paste the data next to each other without even looking at matching the team name. So let's see what merge will do for us. So the default inner join, what happened? So we got our, first of all, the first thing that happened was our team name got aligned. So it did use some intelligence here, because in the second data, DF2, the first team was RCB, but it brought it down. So it did the merge on the basis of DF1, and then intelligently it picked up the corresponding bowler in DF2. Correct. So in DF1, we had the first row was KKR and Gambhir. So then it picked up the corresponding KKR here, Nareen, and then a new row was created. Similarly, RCB and DD. Of course, it skipped MI because we use the default inner join. If I use the parameter how is equal to outer, it's going to also add the last team name MI, where we have a bowler name, but this data is missing in DF1, right? So at the place of the batsman, we got an an. So this is how it works, even if the rows are not neatly aligned. So we were seeing earlier, right? I mean, in the earlier case, at least our IDs were in the correct order. So it was 1, 2, 3, at least up to that point, the order was correct. And then in one data frame, we had 4, and other it was 5. But here, the order was not same, and still it managed to merge them in the correct fashion. What would happen if I concat? It gives me incorrect result because it's just pasting. This is what Concat is doing, Jai Krishna. It's right there. That's why I've kept it here. So you can see the team names are not aligned. It's just literally pasting the data frame next to each other. And it didn't have a row number 4, the first data frame, so we got some nans here. So the blank value, missing value is Panda's way of saying nan. So you will never get a blank here. In fact, there are cases where people want the cell to be blank, not have a nan. What can you do in that case? I'm just digressing a little bit, but it's an interesting topic. So, I mean, let me. So now I have, for some reason, I have this data frame, and the requirement is that I don't want these nan because it may confuse my end user. I just want the cell to be blank. How would I achieve that? You have to go back to your first session on pandas. What did we do? Can you be a little more specific? Anyone else? This question is for all of you. I want. Okay. And then? That is correct, Jasmita. I just put empty strings, quotes. Yeah. So that's how I can achieve the blank cell. Okay. Sorry, I just digressed, but I thought it was important that we talked about it. So this is what is Concat doing, and as you can see, in a case like this where you have a common identifier column, definitely Concat is not something you would be using. So merge is the way to go. So of course we are still on merge. So now I have another set of data frames, slight variation. So now we have a batsman and the team, and we have a bowler and the team name. Unfortunately, here what has happened? Do you see the difference between here and the earlier example? What is the difference? My merge code is not working. Can someone tell me why? What is the error message? It's saying the key error team. Anyone? Yes, the column names are not matching. So in the DF1, in DF2 you can see the column name is team underscore name, whereas in DF1 the column name was team. So when you get a key error simply means that that key error is the column name. So that column name it could not find somewhere. So in this case, what happened? It could not find the column name team in the case of DF2. So that is the problem. So now in such a case, what do you do? So what these are the two parameters that we've talked about in merge so far. So we have used on and how. So now we're going to talk about the next parameter to handle this kind of a scenario. You are getting two different, you have two different data frame. Obviously, you cannot put a condition that my column names for both of them need to be same, and you may not even have the control of changing the column name. So in that case, and you don't even have to, right? So what do you do in that case? All you need to do is you have to tell pandas that these are my identifier columns. You can do that using the parameters left on and right on. So I want to say my left data frame, the merging should happen on the column name team, whereas for my right data frame, the merge should happen on team name. Okay. And in this case, of course, you will not use the on parameter because you're using just left on and right on. So now it is able to, of course, do the merge. The only issue here is that because the column names are not matching, even though you use the parameter left on, right now on, it does not know which column to prefer over the other one. So it has kept both of them. And I've also used how is equal to outer, so it has introduced a nan. Even if I had used how is equal to inner, and the team name, team, both the team columns, the values are exactly the same, still it's going to uh, keep both the columns. And then how do you do, what do you do in that case? Or you have to just make use of the dot drop. So drop, you can use, you can drop either the row or column using the function drop. So for dropping the column, you have to use the axis 1. So that means, so you pass the column name. So I'm just dropping one of them. So I say I want to drop the team. Axis 1 is the column name. So then I get, this is the data frame. So this would be the process in that case. You use the left on, right on, and then drop one of the common columns. Is that clear? Okay. So now we have two more data frames. Now we have a df1. So there's a new column called season. So that's the only change from the earlier data frames that we've been seeing. And the df2 is okay. So there is a home city also. So it just gets a little more interesting. So bowler and the team remains the same. Team name, we are back to the same team name just to reduce the number of complexity in the variables. So, and then there is a season. And I want the merge to happen on both the team as well as season because they both are my identifier columns. So I can do that definitely. All I need to do is that now my on parameter will take a list as an argument, and that list is the list of the columns, and the order is important. So if my precedence is for team name, then I would pass the team first and then season, and vice versa. So I'm saying on team and season, how is equal to outer. So this is what I get. So now my df1, which was batsman, season, and the team, got merged with the df2, which was bowler, season, team, and home city. We are merging on season and team. So even though there are instances where so earlier what was happening, there was you can see that dd is duplicated because in the first case there's domini and season is 2016. Here we have dd, but the season is 2017, so it cannot find the common value. So Zair Khan, there is, the season is 2017 even though the team is the same, so it does not align. You can see there is a nan generated here, there is a nan generated here, and the data is split into two different rows because it has to match both season as well as team. Then only it will merge. Otherwise, it will create duplicate row in case the parameter is how is equal to outer. If it is inner, then what will it do? It will just create only those rows where it can find the common data for both season as well as team. Okay, so now this is the next level. So we did simple merge, then we did merge with columns having different names, and now and we also looked at different kinds of merge: inner, outer, left, and right. And now what if we want to merge on multiple columns instead of one column? So we pass a list of those column names. And the last is you have a fairly large data frame and you just want to merge selected columns. So let's say here, I'm not interested in the home city. I'm just interested in df1, whole of it, and merge it with df2, only bowler, season, and team. So I can do that. Here, instead of passing the entire df2, so instead of saying df1 dot merge df2, I'm saying df dot merge, and then pass the list of this column. So I'm creating a slice of the data frame with these three columns. And then the rest of the parameters remain the same, on the team and season, and how is equal to, let's keep it outer here. So the obviously the home city column got dropped and everything else remains the same. So this is our merge and concat. Is this clear? Is there any doubt whatsoever? And how about others? Because I don't hear from some of you at all. So I would just like to understand, are you all good? There are no marks for class participation, just that I want to make sure everything is fine. Everyone is fine, rather. So all good, right? This is a fairly important topic. You'll be using it for sure. So the ones which are more useful, I kind of focus on them, obviously. Okay. So now we come to another entirely different topic. So we are out of merge. I hope we are all good there. Are the examples that I used in merge and concat, they covered, most of the key aspects. So I hope you should be good using those. So now we come to a different topic called reshaping. Overall, who is aware of the idea and the concept of pivoting? If you've used in, say, Excel or okay, yeah, because it gets used in Excel. So those who have worked with data in Excel would know. Anyone else? Okay, yeah, the idea remains the same. We'll let's see. Okay, so this is my data frame. It's a very simple data frame. I have the indices as 1 and 2, and the column names are ID and the value. What happens if I use stack on it? So we are going to first talk about the stack and unstack functions. So what do you expect by stack when I call stack on something? By stack, I mean I want to stack the values, right? You all know the meaning of stack, right? We are just putting the values on top of each other rather than it being in the tabular structure. So you can say this is a multi-index data frame. This is the level 0. This is level 1. So this is nothing but a series. You have a series with index 1 and ID and then 1 value and then 2 ID, 2 value. And then there are corresponding values here. So you have a 7, B and 5. So this is how you can stack a data frame. You can stack any level of data frame. So this will look crazy, but let me see. You have deliveries. It's a huge data frame. If I stack, what happens? Literally every at on the basis of the index, you can see index 0, 1, 2. Each and every row has got stacked, and your columns have become the level 1 index. So your original index is the level 0 index, the columns are the level 1 index, and the corresponding value. So the match ID, inning, batting team, similarly match ID, inning, batting team, so on. So this is what stack does. You will have your original level of index, then your columns as the level 1 index, and then the values. Is this clear? What is stack doing? This is very important, to understand the structure and what the stack and unstack does. Yes, it's like, yeah, stacking those rings or stacking the toys, literally putting them one on the top of the other. So this is what you get. So this is a series. Of course, you can reset the index. So if I reset the index, what will happen? I'll three columns will get created. Here, these two are just the indices. So in fact, if I check the index of this, there are just levels. It's a multi-index. So there is a level 0 and level 1, and then so there is a level 0, 1, 0, 1, 0, 1, and then the values corresponding to that. Correct. If I reset index, then I get a data frame with three columns. Level 0, level 1. Because it doesn't know the names of these, right? These were just indices at level 0 and level 1. It just gave that exactly that name, what it internally was calling it. So one was the level 0, that is my column name now, level 1, and then this column doesn't have any name. So it just gave it standard, right? Pandas, it doesn't know the column name, it starts from 0. So this is my column name, column 0, and the corresponding values. So this is how stacking works. And the opposite of stack is of course unstack. So for that, to show how unstack will work, what have I done? I've created a multi-index data frame. uh, you can see how to create multi-index data frame if there is a documentation also, but don't worry about it too much. In general, you need to understand the levels. So as I was saying here, when you have a multi-index data frame, the indices are given a number. So this is a level 0, this is level 1. So this is exactly what we had earlier, but I created it using multi-index from tuples. So we have a level 0, level 1, and then there are corresponding values. So we have, and the value is simply a series, right? I have just used a range 1 to 5. So I have those 1, 2, 3, 4. This is my multi-index. If I use unstack on it, what will happen? Now I'm unstack does exact opposite of what stack was doing. So the level 0 index remains as is. The level 1, they switch and become the column names. So every unique level 1 index will become a column in the new data frame, and this is how the data, uh, this is how the shape changes. So this is the reshaping. Are we clear on this? This is definitely complicated, so don't uh, I won't be surprised if you're totally confused here. I'm trying to go slow here because I know the overall reshaping is slightly complicated. Yeah. So what part, up to what part, I mean, were you clear, and then where, uh, don't worry about the use, we'll come to that. Overall, the shape and how does the stack and unstack work, is that part clear? The reset index is nothing. Reset index is any series that you have. Like every time we use group by, it creates a multi-index, right? And then you have to use the reset index. So I'm just applying reset index to create a data frame with a flat structure rather than a multi-index. So that's the only utility of it. What you should be interested in is this: a data frame with multi-index and then the corresponding values. So the first level index remains whatever it was. If it was a default index 0 and 1, it would be just 0 and 1 here. And then the second level is what is interesting. So your columns. So as you can look at it this way: the 1 and 2 is not getting affected. It stays as it is. And this ID valve AB75, only this part of the data, it is kind of flipped by 90 degrees. You can imagine, visualize it as it being flipped. You can say it got rotated by 90 degrees counterclockwise. So this came down and the corresponding values got stacked. So that was the stack, and exact opposite of that was unstack, where these got rotated by 90 degrees clockwise. So now my A and B came on the top, and the corresponding values are under those column names for the corresponding index. So that is the stack and the unstack. Now we will see the utility. So we did see this code, right? I'm There is this, there's a bunch of lines here. At the end of it, what we got is this is my data. So let's say I have data like this. So it's a multi-index. The level 0 index is the batsman name, the level 1 is the season, and then there is corresponding runs. What was happening when I created a plot of it? Do you remember this code? So when I say uh, plot, I get the bar for each and every. So I'm getting a D Villiers 2016, D Villiers 2015, then similarly Rahane 15, 16. This is the kind of plot I'm getting, right? So we had to use the pivot. So in that, at that time, I told you that don't worry about the pivot part of it. So now we're going to worry about the pivot part of it. So ideally, what can you do? I mean, using what we learned just now, I can use a unstack on this. So when I say unstack, this is the structure that I got. My 2015, in fact, let me add a cell here so that it becomes a little more clear and it becomes easy for you to compare. So this is my data frame. And when I use unstack, this is the structure that I get. So my season, as I said, unstack will rotate it clockwise 90 degrees. So now my seasons, each unique season will become the column name. So here the unique seasons are only two, 2015 and 2016. Those became the column names. And then you have the batsman runs. So we got a data frame in this structure. And as I hope you remember, so we using the same thing we can do using pivot. So now let's say this is my, so this is the documentation link for pivot. It does exactly same as what unstack is doing, but you have a function for it. So ideally, instead of unstack, you would make use of pivot and pivot table. So we'll come to pivot table also. So the example here, you can just go through the link. I've given the link here. So there are three key arguments. One is the index, the column, and the values. So in this data frame, this is the data frame that we are pivoting, right? The batsman comparison. Here we had to first set the index. So originally the batsman comparison data frame looks like this. There are three columns. There is a season, there is a batsman, and there is a batsman runs. And we are, what are we doing is that we have to first set the index and then we have to unstack to bring it to this structure. So in fact, let me get rid of this set index here because this is the data we are looking at. Now tell me the use case of this kind of a. So this is of course one use case. We made use of it actually in our matches. But this is something which I have seen getting used a lot. Very common, right? If you have a data in this kind of a format, let's say you have the students. So you have student's name appearing multiple times and then you say you have a student A and then the subject math this much, science this much. Similarly, student B, social studies this much, math this much, science this much. So student C. Ideally, in that case, instead of having duplicated rows, you would want to have the marks, either the marks or the student as the column names, right? And then the corresponding values. That structure of the data frame would make more sense. So in that case, what you do, you make use of the pivot. It takes exactly three arguments. One is the index. So which particular column? So there are three columns here. So which column you want to keep as an index? Which column you want to convert to the columns? So columns is equal to which are going to be my column names, and which is going to be my value. So in this case, value is the runs. So I'm passing index as season, columns as the batsman, and values as the batsman run. So this is how this, as you can see, it's clearly a very neat structure. And of course, we made use of this, but plotting also becomes so much easier, right? With this kind of a data. Yeah, I'll come to set index. So similarly, I can tweak. So my parameters remain the same. I'll come to that also. So I have to answer about the set index and the transpose. Yeah. Now here, what am I doing is that I can flip the names. So here, instead in columns, you can see now I want the season as my column and the index as the batsman. Just kind of the opposite of this one. I can do that, and now I have the batsman names as the indices and the years as the season. This is what we did. It in fact, if I remember correctly, we created a graph of this data. So we had exactly this graph, right? So now going back to the two questions, first I'll go back to the question of Ash. So why did we have to use the stack index, set index, right? So this is my data frame. What will happen if I stack this data? This is what I get. It just literally, see, there are multiple columns here. If there were only two columns and we were stacking, what would happen? It would just neatly stack, right? I mean, just one, say, let's say we had only season and the batsman runs, then it would just stack. There would be season and then, but here, because there are multiple columns, what is happening? The stacking is going to is using the season as the level 0 index, but unfortunately it is using the original index of the data frame as the level 1 index, and everything else it is just stacking. So it is just stacking the seasons first, then it is stacking all the batsman names, and then it is stacking all the runs. Do you see that? Now if I first set the index, okay, let me just so that was my, this is my data frame. It has some indices. I can even reset the index here, to call it, make it 0, 1, 2, 3, whatever, to make it little more clean. So this is my data frame. I still need to print it to show you how does it look like. Let me just print the head. Okay. So this is my data frame. It has season, it has batsman, and batsman runs. If I stack this data, unstack rather, sorry. What is it doing? It is just picking the season. So it got the season, then the indices and the each and every value here. Similarly, if I stack, what will happen? The first level remains the original index, and then it is just literally stacking season, batsman runs, and then for each. So this becomes my level 1 indices, and then the corresponding values come here. So 2016 De Villiers 670, 687, then 2015 De Villiers 513, so on. So this is what happens if you simply stack on on any data which is more than two columns. What can you do is that you can use this, we talked about the set and the reset index, right? So set index, it is creating a multi-index data frame from a single level data frame. So we had a data frame with 3 columns. Now what have we got? We've got a multi-index data frame. So it has the level 0 as the batsman, level 1 as the season, and the batsman runs. Now you can see this is similar to the structure that we saw here, right? This is very similar to the multi-index we saw here, which is ready for unstacking. So here we had a level 0, level 1, and then the value. When we unstacked it, what happened? The level 1 became the columns. So similarly, now for this data frame, converting this level, the level 1, the moment I call unstack, the values at level 1, which is season in this case, will become the column names. And that's what is happening here. If I change the order here, if I call set index season comma batsman, then I will have season first and then the batsman names will become the column names. Is this making sense now? Ash, is this clear? The reason we had to use stack index? Yeah, set index, sorry. So we first created a multi-index, which is similar to what we saw here in the simpler dummy example. And then using unstack was, it made more sense, right? So now the second question that was, what is the difference between a transpose and pivoting? So what is the difference? I'm just going to insert a cell here. So let's say we have this batsman comparison. I'm also going to set the index so that we are at the same. So this is my data, batsman comparison dot set index batsman season transpose. What is it doing? What does transpose do? Anyone? I'll show you once again what was the data frame looking like. Yes, it just literally converts all the rows into the columns and the columns into rows. So here what was happening? Because we had 2 levels of index, those became 2 levels of columns. And my batsman run, it becomes the index. So now batsman run is the only index and there are 2 levels of column. So just the way we have a multi-index rows, we could also have multi-index column. This is the multi-index column. There is a level 0 columns, which is the batsman names, and there is a level 1 column, which is the season. So this is what transpose it is what transpose does. Not something uh, you would desire, right? So transpose is not an answer here, definitely. Though in some ways, yes, I understand the reason one would think, because transpose also, transpose strictly speaking, it flips the data. I wouldn't say it rotates. It actually just swaps the rows and columns. Pivot, you can visualize it as something that rotates the data by 90 degrees. It's just very important to understand and visualize how the structure is going to change once you use. Okay, so now we have a new example. So as you can see, there are multiple, there are 3 columns, A, B, and C once again. So we are just still dealing with 3 columns. And there are multiple rows and there are duplicate entries. So we have a 1A, 1B, 2C, 3A, 1B again, and then there is 1C, and then there is a 2A, and then there is a 1A again. So you can see there are duplicated values in A as well as B. And then there are some random numbers in C. Okay, so this is my data frame. What will happen if I pivot this? I'm getting an error message, and what that error message contains? It says that the index contains duplicate entries, so we cannot reshape. And why is that? I'm saying I want my index to be column A. But what will happen? If I call my index to be column A, which is 1, 2, 3, and then I want my columns to be B, which is A, B, and C, right? But we have a 1A with the corresponding value 0, and we also have a 1A with the corresponding value 9. Now, how does Panda know what to do and which one to pick? So, this is a slightly different case compared to the earlier one. The simple pivot is not working. And what works in this case? This is an example of, so in the earlier case, when we were using unstacking, what were we doing? We were using set index. Yeah, Mayank. Yeah, yes. There is no redundancy in the data. There is a duplication in the column A. So if I want to create, I want to make use of column A as the index and B as the value, then there are certain data points which are getting repeated. So as I said, there is a 1A here and then there is a 1A here. And pandas, we have to specify that which value to pick, because the moment we say we want to pivot this data, we want to reshape this data, what is it going to do? It's going to just create exactly three rows, right? One corresponding to the 1, 2, and 3, and it is going to create exactly three columns. So A, B, and C. So what would you have? You would have a tabular structure with exactly 9 values, but as you can see, there are 12 rows. So we want to get rid of those extra values. Yes, so we would have 1, 2, 3 here and the ABC as the columns. We cannot do that for this particular data frame, right? So first we need to aggregate. And how do we aggregate? We can always use the group by, right? So let's say, and the function is, of course, it depends on your data and what you want to do with it. So let's say I want to say group by A and B, and I want to just pick the first value. I could also have said sum or the mean or the max or the minimum or whatever, but I'm picking the first value for every combination of A and B. So now it got rid of all the duplicate. So we have a 1 ABC, 3 ABC, 2 ABC. Okay. By default, it sorts by the level 0 of index. That's why we have a 3 here before 2. Now, as you can clearly see, this data is similar to what we got earlier with the set index. Here, set index and unstack will not work because, once again, the same issue, right? It cannot work on duplicated indices. So now we don't have duplicated indices. We have unique index. And now when I say unstack, this is the structure that I get. Exactly 3 rows and 3 columns. And the remaining values got dropped where there was a duplication. I could have used a sum here and then the values would have got added. I could have also used a mean here. And I got the mean for every combination. So this is, and the same thing can be achieved using pivot table. So as I, when I started pivot, I said that there are two functions, right? There is a pivot when there is no duplicated index and then there is a pivot table, it has one extra parameter other than your index column and the values. So index columns and values remain the same. We have to specify what should be my index column, what should be the column names, and what should be the values. The only difference here is that what function, on what basis do you want to aggregate the data, which is essentially same as grouping. After grouping, you have to specify, right, that how do you want to aggregate the data. So the same thing you are doing here. You are saying that I want to aggregate the data by the mean, and I got exactly same result as I got with the group by and unstack. Are we clear on this now? So we essentially learned two things. One is we can, if there are no uh, uh, duplicates in the indices, we can use set index and then unstack. If there are duplicates, we can use group by and unstack. And the appropriate function to use in both the cases would be, in the first instance, it would be pivot. Parameters remain the same, index, columns, and the values. In case there are duplicate indices, you need to aggregate, right? Otherwise, pandas won't know which rows to keep and which to drop. So, and obviously, as the name suggests, there's an appropriate function called aggregate function, and you specify the function name and you get this output. It's a very useful function. Are we clear on this? So don't worry if you don't fully understand the unstack part, the set index and the unstack, or the group by and unstack. In fact, the purists of the pandas, they say that you should not even use this because there is a function written for it, right? So this, they consider this to be more hacky. The reason I use this is that when we do this, it becomes a little more clear as to what's really happening. Pivot, it looks like a magic, right? I mean, that I just say that pivot table and then pass the column names and my data is just magically reshaped. So here I can step by step show you that what's really happening, what's going on internally. So that's the reason I'm keeping this code, so that it becomes clear. But once you know the utility, ideally you would be using either the pivot or the pivot table. It's just important to understand how is it working. Everyone? I just need to know because this is a fairly important topic. In fact, even for Excel, I've seen many jobs in Excel where they say that, okay, you should know pivot. I mean, that is something which is the highlight kind of. So, okay. So, the next topic, melt, which is exact. Aggregate function is, okay, this is my data, Mayank. So, we have column A, B, and C. I want my A to be the index. So, I'm going to have 1, 2, 3. And I want this ABC as these ABCs as the column names. So what will happen? At 1 and A, it got a 0. It will put a 0 here. Then 1 and B, it got a 1, 2 and C. Similarly, it is just filling up this table. Now, what will happen when it encounters this 1 and B again? There's already a value 1 and B. We already have placed 1 over there. What do you do with this 4 now? Do you see that? What is happening here? In fact, let me make it first so that it becomes clear. If I start populating this table, 1 and A, 0, 1 and B, 1, 2 and C, 2, C, 2, 3 and A, 3A, that is 3, 1 and B. Now it got once again 1 and B, but we already have a 1 here. So what do you do with this 4? Pandas doesn't know that, right? I mean, it will do exactly as you specify. So you need to first aggregate the data. You need to specify that do I want to keep my last value? Do I want to keep the first value? Do I want to add the values if there are duplicate indices? What do you want to do? That is truly the aggregation that you do even with your grouping, right? I mean, once you group the data, you need to specify the function. What does the group by return? Group by just returns an object, right? This is what it returns. It just creates an object. After creating an object, you need to specify how do you want the data to be aggregated. Similarly, even in pivot table, when you have duplicate indices, you need to specify the aggregate function. Then only it can give you a meaningful outcome. Okay, so the melt is going to be exact opposite of pivot. So we used unstack and pivot. Here we are going to use stack and melt. So it's like you were able to create the data was stacked and you were able to create columns out of it. Now we have the data in the column structure and now we're going to uh, stack them one below the other. So that is what you would do with melt. Yeah, the mean is the mean of those values. Like in the group by, that's why it is more clear here. If I pick only if I use the function first here, what happens? It just picks up the first value it encountered. So now when it sees 1 and B again, it ignores it because there's already 1 sitting here. Similarly, 1 and no, 1 and 2 and no, 3 and B. So 1 and C. Okay. So there's a 1 and C, there's a 5 sitting here. So it will ignore this 8. But if you, so in this case, what I have done is that I've kept the first value and then ignore the next. If I don't want to do that, I can use the function mean, in which case, whatever is the duplicated indices, whatever values it corresponding to that, it will take an average of that. Okay. So do you all want a quick break before we start the melt? Are you all able to hear me? Okay. We can continue. Okay, perfect. Okay, this should be easier, I'm hoping, because we already understood the concept. So now we have the data in this structure. So let's say I have the names of various people and don't ask me what does that mean. And then there is a corresponding year, right? But what I want really is just 3 columns. I just want the year, I want the names, and I want the corresponding values, which is exact opposite of what we did earlier, right? So how can we achieve that? I can achieve that using, now I'm going to use set index once again. Set index you have to still use. So my indices I want at the level of the year. And after setting it at year, I want to stack it. So this is what I got. So the year, now it is a multi-index. So once you use a set index and the stack or unstack, you get a multi-index. So we got a level here and then there's a level at the name and then the corresponding values. Of course, I can make use of reset index to get something like this. And as you know, when you use reset index, it does not know what to do with the column names. So it does not know the column name. So this is my level 1 index. It just created the name level underscore 1. And for the value, it just created a column name called 0. So I can use the function rename, and columns is equal to, it takes a dictionary as an argument, and this is the data. This is the structure I get. Now what happens if I directly use a stack here? Before someone asks me, let me just address it. So instead of using set index, directly using stack, then this is what I get. And only issue here is that I have my names neatly aligned, which is what I want. My only problem area is this, the year, which doesn't have any use in this column, right? I mean, it does not sit here. It shouldn't be here. So if I use a reset index, the data frame that will be created will not give me the right structure, what I would ideally have expected, right? I want the year column to be a different column because it has no job sitting with the names. So that is why it becomes important to first use the set index and then stack. So what did we do earlier? We for pivoting, we use set index and then unstack, and now we are doing exact opposite. We are saying set index and stack. Now the same thing what we are doing here for the same data frame we can achieve using melt. So now the variables, the parameters are slightly different. So instead of index, it is ID variable. So I want my ID variable to be year, and the variable name. So I can also specify the name of the column, because I had to see, I had to use the rename, and I had to use multiple things here to give it, because once I stack this data with year as an index, it does not know what to name these names, right? So I'm specifying the variable name as the name and the value name as whatever is the I want to create. So here we had to use a rename separately. The level 1 I gave it a name, and the column 0 I gave the name value. I can do that within the function melt. That is why overall melt and pivot are preferable over using stack and unstack. And I got exactly the same outcome as I did earlier. Only difference being that here I was using the set index and the stack. Here I'm using melt. Let me just print the head so that becomes a little more visible on the screen. So this was my original data where my names were as the column names, and then there was a corresponding value, and then there was a year column. So I did exact opposite of pivot here. This was one example I had seen I think I had in Stack Overflow. So let's say this was a data frame. I think somebody asked the question and I answered. So this was there's a part 0 and part 1, and then there is some corresponding time column. So I want this just to be a part column called part, and then 0 and 1. So how do you do that? You can say once again melt. So ID variable should be the time, because that I want to be repeated, and then the variable name as the part. So I get this, right? So something very similar. Melt is also renaming, yes, because you are able to name your variables. So there are two parameters here, which is doing the job of renaming: the variable name and the value name. So the variable name is basically the name of that column, which were earlier the columns, right? The column names, because now these column names have become the names of the column has become one column by itself. But Pandas does not know what to name them, right? Sorry, not the year part, only this much. So it is taking care of that, and I'm saying that my variable name should be given the name this, and then the value name should be called value. So it entirely comes to the stage of your pre-processing of the data. If your data comes into a structure where you have multiple variables which are not in the desired format. So let's say, let me think of a use case. You are working on, say, gene sequencing, and then there are different gene IDs which are aligned here. You have a you or maybe you have the IDs 1 and 2, and then the corresponding uh, the say the sequence 1, sequence 2, and sequence 3, and the IDs, but you want them in one line. You just want each you just want exactly the column according to the sequence ID, and you don't want those values separately featured as column names. I can search up some more examples, but this is a pure reshaping. So this would become a part of your pre-processing. If your data comes to you in a format where you cannot see, end of the day, when you have the data, you have to look at everything as uh, right now we are looking at a data frame. So we are calling it as a row, and we are calling it these as the columns. But now in two sessions, we are going to look at the observation and the features. So let's say this is my data. I have two observations. The first observation is 2013 and the second observation is 2014, and it has these six features: Amy, Bob, Carl, Chris, whatever. Right. These are my unique features which I'm going to feed into the algorithm. So that is how you have to look at the data really. And uh, each row, it represents each unique observation. But let's say you have your data where the observations are duplicated and the feature names are getting stacked like this. Then what do you do? Okay, let's say we have simple example. We have Titanic data. We are working on Titanic data set. Apart from the other columns, it has, so we want uh, we have the name of the passenger and the passenger class and things like that, right? Now we are looking at the sex column, male and the female, correct? So if you want those male and female to be two distinct features, then how do you do? Because otherwise you would have the name and then correspondingly it would be either a male or a female. There would be a M or a F. But if you want those to be two distinct features, what would you do? You would have to pivot this. You have to use the name of the passenger as the index, and then that the values in the sex column should be converted to column names. So that's how you created two distinct features. Of course, for male and female, there is a way to handle it, but I'm just for the example sake that if you have get data and the corresponding value getting duplicated, but you want them as the features, then you have to do the reshaping first. Okay, I shall come to that. Does it make sense? I can look at more examples of the use case, but it entirely depends on how, in what structure are you getting your data, and what are you going to do with it. So let me look at a couple of real examples that I have worked with. That will make it a little more clear. Okay, so now a couple of other questions. Difference between unstack and reset index. What does unstack give me? See, this is the output of my unstack. What do I get? I get multi-index columns, right? Reset index, it nothing but resets this index. So reset index means this index becomes column name. So literally it just, now my batsman has become a column name. So that's what a reset index does. In any case, it has nothing to do with unstack really. In any scenario, we have used a reset index along with grouping. So whenever there is an index, so you can in fact use a reset index on this kind of a simple data frame, flat data structure. We have this batsman comparison, right? If I use a reset index, what will happen? Can you tell me, Ash? Or anyone? This is not a multi-index data frame. This is my data frame, season, batsman and batsman runs, and indices as 0, 1, 2, 3, 4. If I use reset index on this one, what will happen? No, that's not correct, Aruna. Anyone else? I'm in a way glad that Ash, you asked this question because it becomes important to understand what's happening. No, that's also not correct, Mayank. There will be a change, but what would be the change? Any more ideas, thoughts on this? Anyone? Exactly. So it will reset the existing index as the column. And whenever that happens, it will create another index. So now my original indices, which were 0, 1, 2, 3, that became a column and another set of index got created. But here, because originally the index was anyway 0, 1, 2, 3, 4, 5, this is really irrelevant. But in a case like this, where my index was the name of the batsman, in a use reset index, what happens? This batsman, the indices, it becomes a column. So that's what reset index does. Is it clear now? See, I can, it's the same as the drop is basically dropping the column name. We used it even earlier. So drop is used to drop. So let me use it with, let's say we have this data frame, DF2, bowler, season, team, and home city. I want to drop the bowler. Okay, first let me say I want to drop the first row. How will I do that? I would say df dot drop and 0. So what am I passing? I'm passing the index. What happened? My index 0 got dropped. And now if I print df2, what will I get? Sorry, df2. I'm still getting the original data frame because this is not an in-place operation. So if I want this operation to be, no, it's nothing to do with sorted. It is dropping at the index level. If I say drop 2, drop 3, what will happen? Now the Malinga got dropped. We have index number 0, 1 and 2. I can drop 2. So now I have indices 0, 1 and 3. Index 2 got dropped. And The reason I have to use in place parameter is that because this operation is not in place. So either you say df2 is equal to df2 dot drop, or you say df2 drop index number 2 and then in place is equal to 2, right? Now if I want to drop the column, say now instead of dropping the row, I want to drop the column bowler. What happens? The label bowler is not in the axis because it is looking at the index called bowler and it cannot find it, and that's why you have to use. So now you have to tell pandas that I'm talking about column name, which is axis 1, right? So I'm not talking about the row here, I'm looking at the column. So now the bowler got dropped. Once again, you have to either use in place is equal to true, or you have to assign it back. So you have to say df2 is equal to df2 dot drop. Is that clear? In place will store the changes. So once I say in place is equal to true, and now if I print my df2, the changes have happened already into the original data frame. Okay, so back to the melt. So this was just another simple example. So there are two columns with different parts, and then there is a time. I want this part to be as just one column, and ideally I would want just the part number, not all the gibberish. We'll address that. That is our next topic. That is why. But the melt can handle this kind of a use case. So this was just talking about another use case. I'm also trying to find more use cases, more relevant examples so that it becomes a little more clear. Okay, so Wes McKinney is the person who's written pandas. So I just came across this. Uday, I was just it was a valid question because sometimes it becomes difficult to visualize. Why would you need it? So let's look at this. So this is another data frame which is used for academically for data science a lot. So we have this is the head. This is how the table looks like. There's a bill, tip, sex, smoker, day, time, size, and percentage. Okay. Now I want my data to be split by the time. So the time column has two distinct values, lunch and dinner. And the sex column has two distinct values, male and female. I want to create a tabular structure where I want to see the response for the time and the sex. And what am I doing here is that I'm getting the rows, the time and the sex, and the tip percentage. So there is a tip column and then there is a tip percentage. Correct. And I'm also looking at whether how many were smokers. So I could use a pivot table to address that. Note that there is no aggregate function used here, the parameter. And why is that? Because the default is mean. So as long as you are finding the mean, you don't have to. So now you can see the data, which was like a simple flat structure where it was very difficult to visualize or categorize the data as per the distinct category. Now this data makes more sense, that at the dinner time, amongst female, these many are not smokers and these many are smokers. Similarly, amongst male, these many are non-smokers and these many are smokers, and so on. Similarly, I could structure it by day and the time. So I can say Friday, this was the percentage. So, okay, now we are looking at the sex. So now the column is equal to sex. So male and the female. So on Fridays for dinner, you see, on an average, these many females and this many male, and similarly for lunch. This is the structure. Then Saturdays, Sundays, Thursday, it could not find the data point for male, so it just returned an and here lunch is this much. So you are able to convert the data into a format where it becomes easy to look at the observation and the features more easily. And you could do it on the basis of multiple different conditions. So you can see that he's just playing around with different columns. That now there is a sex and smoker once again, and the rest of the columns remain as it is. So I'm saying the size, the tip percentage, and total bill, they remain as is. In which case, what he's done is that use only the rows parameter. Row is equal to sex and smoker. Of course, the parameter. This is an old article written by him in 2011. So the parameter names have changed. So this rows has become index now. But overall, you can see the utility of it. Does it make sense? And then the similar uh, uh, utility, but making use of unstack. So, and then there is this article, of course, it also compares it with the R. There is a reshape. So most of these functions, there is a corresponding in R. Of course, I mean, pandas came later. So R was already existing. So how would you do something similar using R? So there is a cast, and there is a melt also. So melt is very similar to the melt that we talked about in pandas. If you are interested, this is the link. Okay. So now we have completed the melt and the pivot, the overall reshaping. And so, as I said, we were on the last example where I just am interested in the time. Of course, it's my index and it's just one integer time, 012. Does not look very relevant, but let's not worry about it right now. For the part column, I'm not interested in this part underscore 0 underscore hit. All I'm interested in is the part number, which is 000 and then 111. How do I do that in this case? So for that, you would do something called as the entire topic of text manipulation will come into play in that case. So there is something called as string methods in pandas, and surprisingly, I have not. Okay, so no, this is the get dummies. Okay, we still have to talk about a couple of other things before we move to the string. So we can hold this right now. Okay, let's complete a couple of other things before we move to the text data. This is a very, very large topic. We're going to spend some time on it. You will use this also a lot. So as I was telling, your final project, the IMDb data, the sentiment analysis, it also largely uses the string methods. So, okay, before that, just a couple of things. We don't worry about this too much because we are going to use in machine learning but we are going to use scikit-learn package. So this is my data frame. As you can see, there are some values which are unique, some which are separated by commas. Now what I want to do is that I want to find for each index, I want to find uh, whether that observation is present or absent. So you will understand this better using, I'll show you. So what it does is that for each unique value present in this separated by comma, because I've given the separator as comma, it creates a column name, and then all it does is that it checks 1 and 0. 1 means okay, at index number 0 A is present, AB is absent, B is absent, C is absent, D is absent. So there's a 000 here. So the simpler, interestingly, I've just used the examples which are okay. So this is another example. There is, so this is once again used for we'll use this a lot, in fact, for machine learning. So uh, when you have multiple values here, what happens, as I was saying once again, right, that for machine learning, each unique value is one feature. So if you have multiple values here, which could be separated by comma or you know, uh, so the idea behind, I don't know if you've heard about overall the tidy data set. That was the concept which was introduced in R, that there were some principles of tidy data set. So each unique observation, which is basically one row, so each observation should be in one row, and each feature should have exactly one column. If it is split into multiple columns, then also it's a problem. If one column has more than one kind of a value, then also it is a problem. So you need to tidy the data set. So all the pre-processing that we have learned to do in pandas, that comes as a part of, the tidy data set in R. So you do the same thing, I mean, making use of the functions available in R. So this becomes a part of that concept. So we do have just one column, but you can see there are various different values present in one column. But there should be only one column, should have only one observation, one set of observation. You can't have multiple, because you cannot pass this data to the machine learning algorithm. It cannot make sense out of it. So what do you do in that case is that, now what it does is that for each observation, it knows that at observation 0, A is present. At observation 1 or at observation 2, A, B, and D are present. So something like that. So it makes use of the data that way. We will, if you don't understand it fully, don't worry about it. We'll kind of revisit it for machine learning. We'll be heavily using it, in fact. So this is the concept of get dummies using pandas. And in fact, we'll use a scikit-learn package. So you don't even have to worry about it. So this was another example where the separator was the piped character, which is a default separator for get dummies, interestingly. So we don't even have to use the separator in this case. We just say str.getDummies and we get our data into the correct structure. Similarly, there is another kind of a data frame. So let's look at it. How does it look like? These are all kind of, the part of the reshaping. So we have a data where there's a drug ID and then there is an illness associated with it. What I'm interested in is that I want to create a cross tabulation of for the combination of drug ID and illness, whether the observation is present or absent. So I hope you all understand the meaning of cross tabulation. So it is in a way similar to pivot, but without a third column called corresponding value. In pivot, what we do, there is a corresponding value. So we use one column as the index, one column as the column name, and then the corresponding value becomes the value associated with that. But here there is no third column. All we are doing is we are trying to find the presence or the absence and the count of it. Correct. So for example, this Lexapro 2 has is for that the illness MS is appearing twice. So what am I doing here is that I'm just trying to cross tabulate it and find the number of occurrences of the combination. So it created an index of each unique drug ID, and it created columns out of each unique illness. And for that combination, it created a cross tabulation that for Lexapro 1 CD, there's zero observation. But for Lexapro 2 MS, there are two observations. Lexapro 2 HDED, there is one observation. So this is once again used in drug sequencing. So this is a real example that I made use of. But once again, so this is not the structure that you would use for machine learning. If you want to feed the data, this data to the algorithm, you need to first convert it into this numeric format. See, ultimately what happens is that before the data is completely ready to be fed into the algorithm, every feature has to be in the numeric format. So what do you do with all the text data? You have to somehow convert it into the numeric format. So this is when you're counting the occurrence, you're making use of the crosstab. Is this clear? So we will revisit these two definitely. So don't worry about it. Is everyone with me on this so far? Are we going too fast? Is there any problem, any issue? Please let me know, because when I don't get too much response, I just see this is like an online session. So the reason I keep asking is that I don't know what's happening on the other end. I cannot see the expression. If somebody's dozing, I cannot see that. So as a person who's talking, it becomes important, right? So are we all good to move to the next topic? And I hope it's doesn't feel too much. Not much dosing, good. Okay. Fine. We are ready for, we can take a quick break. Yeah. Okay. Let's take a quick break and then we can come back. In fact, on just on this, the topic of what I'm saying, that, I need to understand what's going on. So I was having a session with other instructors of Digital Vidya, and then one person was talking about one new data set that we introduced for as the final project. We added another project. So he was explaining, and then every 5 minutes or so he would ask that, "Are you all with me? Are you all with me?" And then that's when I realized that, and I was feeling like, okay, we are all good. Please go on. But as an instructor, you don't know what's happening on the other end. So it becomes important to know. So that's probably the reason I keep asking. Okay, so break it is. We'll be back in 4 to 5 minutes. So I'm here. If anyone has a doubt while we are waiting for others to join in, you can ask. Okay, Aruna. I'll take a look at that. I'll let you know. Quickly confirm, yeah. Others, just if I get a quick thumbs up, then I can move on. So this string methods is the last topic in advanced pandas, and then of course we'll move on to there are some miscellaneous topics at the end. So this working with the text data is a fairly exhaustive documentation. I obviously I've not even used all of the functions in my document that I've created. So you will have to. I would highly recommend that you use take a look at the documentation as well. Uh, so okay, I'll start with the example directly. So let's say we have this data frame. Uh, there is a lot of so there's a player name and the team. As you can see, there's a lot of junk in the team name. So there is the data is not at all clean. Now, if I want to find how many teams are present, how many unique team names are there in this data set, what would I use? I would use a value count, right? So it's a series method. So the df team dot value count. What am I getting? I'm getting just literally I'm getting 111 because each observation is unique. These are strings, right? So as far as strings are concerned, I hope you all remember we spent quite a bit of time in Python strings also. So if you remember, we used the example of Sachin. So if I say Sachin equal to Sachin, will I get true or false? Will this equate to true or false? It will equate to false because there is a capital S here and there's a small s here. Similarly, even a space has a value. So Sachin Tendulkar and Sachin Tendulkar, these are not the same, correct? Because the space has a value. Similarly, if there is any character added, a number added, it has to be exact. Otherwise, the strings will not match. So that is the reason we are getting this. And this, though this example is very dummy and it looks very forced, and it is forced, of course, I have just added the gibberish here. But uh, interestingly, in real world, no text data is clean because typically all these text data, it is manually typed, right? And whether it is going back to the reviews, IMDb reviews, Amazon reviews, people put reviews in Amazon. Some people like to type in all capital, some people type in small, people type in short, they use wrong spellings. So the text data, the real world text data is never clean. So though this example looks a little forced, but the use case is true. So let's say, how do we handle this? So the methods are the functions are more or less the same. Of course, we are going to use it in reference to the pandas, so we are not going to use the pure Python functions. But can you all tell me some of the things that we need to do with these? Let's say, let's handle it one by one. So we have this KKR at 3 here, and then we have this KKR 3 here. How do I make it uniform? What will I have to do? Let's address it one by one. So, anyone? Yeah. So first we need to drop the add character. We have to search A to Z and A to Z. So basically we need to uh, uh, make the case uniform, right? So it either we can have all of them in uppercase or all of them in lowercase. Drop the characters, drop the numbers. Yeah. So that should most likely be it, right? We drop the characters, we drop the numbers and make it uniform case. So for all of these, as I said, there are string methods. So they are all, they start with the str accessor. So instead of using the your series or the data frame dot lower, you would say these are series methods first of all. These are not the data frame level method. So essentially, you need to remember that they are going to work on the series, and you need this str accessor to use the function. You can use the Python lower, but then you have to apply, and apply is definitely slower. In any case, wherever you can use the vectorized operation. What is the vectorized operation in pandas? Where the operation is happening row wise, not apply. Apply is pandas way of creating a for loop. So I can use Python lower and upper and whatever, but ideally I would use the string methods. So what is the first thing I'm doing? I'm saying dfteam.str.upper. So if I use that, what happened? All my, at least my alphabets have been converted to the uppercase. Okay, so that's my first step. Let's do it step by step rather than hurrying into it. So now when I call value count, okay, it's become slightly better. At least now I got MI5 and DD2, two instances. So it's looking a little slightly more clean than it was originally. Then I'm going to make use of uh, extracting. So either I can, so now what am I doing is that I want to either, I'm making use of another function called str.extract. And so there are two. There's extract and there's extract all. This is making use of the regex. So I'm going to explain regex in little more detail. But uh, the short right now is that if you want to only extract the alphabets, you use capital A to, so you can use either A to Z, A to Z if you want to extract small as well as capital characters, and if you want to use only capital, you would use A to Z. So this is called A to Z, and mark, please remember this is in the square bracket. The plus means that I want to extract one or more. So from each, the entire column name, I want to extract one or more instance of any characters between A and Z. Okay, so that is the str dot extract. Anyway, take a look at this document, please. So that's very useful. So now what will happen if I'm extracting only A to Z? That means it, so this it reduced the number of steps rather than having to drop the number as well as character. What I did was I just extracted the A to Z, so everything else automatically got ignored. Now you can see my team column is a lot more clean. Now there are multiple ways of doing it. This was of course using the regex. Let's look at other ways of doing it. So another way of doing it is that we can also use something called as replace. So going back to the original example, let me just, because I made the change already, here you can see that I have already saved that into the df team. So I'm creating the data frame once again. I would still have to convert everything to uppercase. So let's do that. Df team, it has become uppercase. Now I can say df team dot, there is a replace also. So I can say Once again, replace also takes regex. So I can say anything which is not alphabet, or there is a regex for the number and the characters. So backslash w will remove all the characters. So don't worry about the regex part. Yeah, I will explain that in detail. Actually, I yes, regex is coming right here. The next topic is that. So don't worry about it. So this is backslash w is characters. Okay, and then you also replace the numbers. So this is another way of handling it. I'm saying is that there is no one standard way. There are multiple options available. So you can either use extract or replace. Extract is extracting what you want. Replace is replacing what you don't want. So this is kind of an opposite of what extract is doing. So I can say replace these characters. I can also say replace these characters or 0 to 9, and it replaced the characters as well as the numbers, and what remained was this. So the same thing that we used extract for, we performed using extract, we can do the same thing using the replace. So we are replacing every character as well as every number. So we are just coming to so another is from the name, the player name. I want to remove the underscore. So if you remember, we did that in the string when we were doing Python string, right? I mean, if you have uh, any character, you can replace it. So I want to replace this underscore in the names. As you can see, our names of the players are, this is my data. The names of the players are separated by underscore. So I can say replace underscore by, where is, yeah, the space. So now if you see the data frame, of course I reloaded that this part and I did not. So this also takes, okay, this str dot replace doesn't have in place arguments. I just need to assign it. Okay, so this is assigned. And now if I check, I replace the underscore, I get the player name and the team names which are already cleaned. So this is just one way of cleaning the process of cleaning of the text data. You can also create use split if you want to now split your names and the last name into two different. So you remember we used split in, once again in Python we use the split. And what does the split return? So I have my string called Virat underscore Kohli and I'm using str.split with the separator as underscore. If I execute this cell, what will I get? What does the split on a string return? Are you sure? Yes, it returns a list. Please remember that. Split, it returns a list, and a join on a list returns a string. And these are the things you will be using, in pandas, because when you work with text data, there would a lot of manipulation would be required. So this is it's returning a list, and then I'm using the index. So if I say 0, I'm just picking the value at index number 0. So I get the first string, which is Virat, right? So this was just a reminder on Python string. So I'm loading this data frame once again. And what am I doing? I want to create two different columns. I want to create a column called first name and a column called last name. If you remember, your Python assignment was something to this effect, right? There was a name and the last name. Of course, in that we did it It was a dictionary and we had to use the loop. Here, all these operations, they happen, these are vectorized. So your split is also working on row wise. So my player, I split it, and then the zeroth element, basically the first element, I'm saving it to first name, the second element, I'm saving it to the last name, and then I'm dropping the player name. So this is the data frame that I get. The team, of course, I've not made any changes here because I loaded the DF again. So it still has all the uh, unnecessary characters and numbers, but our first and last names, we are able to create two different columns. So these are the kind of functions which are available. Now, of course, there are many more, and we are going to talk about some of them, but let's focus on the regex. How many of you are aware of or have worked with regex? You are very comfortable with regex? Anyone else? Perfect. Okay. So far, two people. Okay. SQL, yeah, it makes use of it to some extent. Okay. Well, there you have it. So regex, it's in a way, it has its own world. So when you look at any code which uses regex, it looks totally confusing. It looks like a jumble of characters. So for example, this part of the code, it is making use of a regex. It looks totally confusing, but you need to understand every element of it. So I will try to explain it here. I started introducing in when we use the extract, but now let's go systematically one by one. So if you want to extract from any string, say, uh, any number of elements. So if you want to extract zero or more element, in general, the something that gets used, you can see here, right? The star, the dot star, that is the most common. So zero represents, the star represents zero or more, and plus represents one or more. What does it mean? That plus will return only if there is at least one character. We will come to that, but yeah. So typically, when you want to just extract everything from a string, what you use? You say dot star. That means just everything that is present, right? Plus dot plus is one or more elements. Backslash s, it represents the space. So if you want to either extract or replace a space, then you use the backslash s. You can also specify the number. So you want to specifically say extract three spaces. Then you can say backslash s, and in the curly bracket, you can specify the number. You can also do that using the date. So you can say backslash, sorry, so similarly, just the way there is a space, backslash d represents the numbers. And if I want to say specifically extract only the places where there are, say, five numbers in a row, I can say this. So it will extract only exactly five numbers. So you can specify the number here. Similarly, we used already A to Z. All the alphabets. Please notice the space here. It's very inconspicuous, but yeah, it has a value. So all the alphabets, including the space. So if there is a string which is separated by space, then you have to specify the space here. A to Z 0 to 9 will extract alphanumeric, and there is another easier short character for alphanumeric, which is backslash W, the small w, please notice. Capital W is for everything but alphanumeric. So we made use of the capital W here, right? When we used the replace using the backslash W. So when we said replace backslash w with a empty string, that means everything which was a character, whether it is percentage, this ampersand, all those characters got replaced by empty string. So basically they got removed. When you are replacing something with an empty string means you're removing that, eliminating that. So now with this knowledge, let's go through it one by one. Now we are going back to the same data frame. I'm loading it once again. We're not bothering about the team column right now. We are looking at the player. So you know the players are separated by underscore. And we also know how to separate them into two different columns. What did we do earlier? We used str.split, and then we had to use str0 to extract and save the name into the column called first name, and then we used str1 to extract the last name and save it into the column last name. Now we can also use the regex. So we can simply say str.extract. Extract, it requires a capture group. So it will only capture everything which is inside the bracket. So now what am I telling the regex is that I want to first capture everything till it encounters an underscore. So everything which is before the underscore, and then pretty much everything which is after the underscore. And what I get? I got my first and the last name. Of course, I haven't dropped the player column, so it is still present here. In this case, I also dropped the player column. That's why it disappeared. So this is the first example using just everything, as I said, right? Dot star is just extract everything. So does this make sense? Is this clear? We'll go through this all of it one by one. Don't worry, but just the first example. Not clear? Okay, so the str.extract, it has a parameter called expand, and when you use expand is equal to true. Okay, that's a good question actually. So because I need to show you what happens if you don't use that. Let me comment this out, and yeah. So what is this returning? I'm capturing, there are two extract groups. So basically I'm getting two distinct values out of this data, right? Expand is equal to true is going to give me two distinct columns. So it all, you can see it created a column, and because pandas by default, what is it going to do? It's going to give the column name 0 and 1. So that's what it did. And then after that, all I did was I just saved it to this name first and the last. So I assigned those two columns the new names. The names I assigned were first and the last. Now what happens if you use expand is equal to false? Okay, it is still returning. I'm surprised. The default behavior, I think it's more relevant. Let me show you with single capture group underscore. Okay. So this is everything before the underscore. So expand is equal to false, expand is equal to true. It returned the first column. So it returned a data frame with a column. Whereas the false, it returned a series. So the assignment in this case is not possible. When you have a series, you cannot give it a column name. So I cannot say df first here. Okay, it is still able to create a series out of it. But it's basically right now it is a series, not a data frame column. I'll tell you the context behind specifically using the expand. Let me go to the extract. I hope this is the latest. Yeah, it's point 23. So what happened was in the latest version of Pandas, there was earlier the extract. Sorry, str dot extract. Yeah. So from version point 18 onwards, expand is equal to true. It returns a series, index or a data frame, and true it always returns a data frame. So false, it depends on how many extract groups do you have. Whereas when you have a true, whatever, how many number of capture groups do you have, it will still return a data frame. So this was the change, which was, so the default is expand is equal to true since version 23. So what was happening was earlier, till this, before this version, the default was false. So whenever you would use the code without, I think I have pandas 20.22, not 2.23. So what happens every time if you don't use the expand parameter, every time you get this future warning that currently extract means expand is equal to false, but in future version of pandas, it's going to change to expand is equal to true. So it's already changed. I have to update my pandas. So that is the reason it becomes important to every time specify the expand argument. But if you are working with pandas 0.23, then you don't have to worry about it, particularly if your capture group is only one. Okay. So just to avoid this warning, every time I'm using extract, I make it a point to use the expand argument. And whenever you are creating multiple columns out of it, you would by default use expand is equal to true. So this was the simplest, the regex at its simplest, right? Now the second example. Now I'm using extract backslash d plus. What will this return? Now I'm looking at the team column, this column, not the player. I'm just using extract with different regex arguments so that you know all of it is clear. Anyone? Yes, it's only capturing the first group of numbers. Please also note that in this case there was 100 and there was a 5. It only captured the first occurrence. And why is that? Because it strictly follows the capture group, and this second set of numbers, the 5 here or a 3 here, would come as a second capture group because there is some string in between. So this is ideally a, for particularly for this case 100 RCB5, it's more a case of backslash d plus, and then say you can even use dot star, that's not a problem, and then there is another group, capture group with backslash d plus. Why are we using plus here? Because if there is no number, then it's fine, it will ignore that. Oh sorry, it has to actually at least capture one. So but in case of using this regex, what will happen, the cases where there is only one occurrence of number, there it will create a problem. So it created two different capture group with expand is equal to false, expand is equal to true, and the places where it could not find two different set of numbers, so there was a RC 100 with followed by some characters and 5, so it is happy here 4 3, happy here, but here there's only string and then the number. It could not find anything. So there it wasn't too happy. So we can use a star instead of that. But still it is capturing that and then ignoring the rest. So this was purely extracting one set of numbers. And numbers you extract using backslash. So the key thing here is that remember the most commonly used. So dot star is your extracting everything. This is the gist of uh, the regex arguments. So dot star is extracting everything. Backslash s is space. You don't have to worry about too much. But A to Z is all the alphabets. Backslash D is number, and backslash W is the characters. Everything but alphanumeric. So now what are we doing from the player? Player is once again the names of the players separated by underscore. We want to extract all the names. So why did this happen? Why am I only getting the names? Yeah, why is it not giving me the last name? Because my player column, if you see, it's Virat underscore Polly, Zahir underscore Khan, but I'm only getting the first name. Yes, so I unless I specify an underscore or I create two capture groups. Yes, so it stopped at this place. But even with this, because there is no underscore, so it does exactly what you tell it to do. So what am I saying here is that extract everything along with the underscore. So it is also keeping into mind that I need to take care of the underscore. So in a way, regex is very, very precise. You just have to exactly give what you want to extract and it will do the job for you. Now backslash W plus what will it do? For now we are back to the team column. So it is extracting the number and the alphabets. So alphanumeric, right? Backslash W plus small w is the alphanumeric. It only discarded the characters. Similarly, earlier we used backslash capital W. What it does is that it extracts all the characters. So in the first column, there is no character. There's only number and the alphabet. So we got an an here. In the second, there was a percentage. Here there was this sign. I don't know what is it called. So accordingly, wherever it encountered a character, it returns that. Rest of the places, it returns an an. So this is how you make use of different arguments in the regex to uh, string in between of numbers for the team column. Okay, so what I can do here is that let me load this once again. So now df dot team dot str dot sorry replace it by, and I also want to replace the characters. So then I get the numbers. So basically I'm just replacing everything, which is if you were asking that using the extract, what will happen is that extract will give me two distinct capture groups. So whenever I'm capturing, say, a number, and then I'm ignoring the alphabets, and then I'm capturing another set of numbers, there are two distinct capture groups. So it will create two columns, and then I have to combine those columns. There is no direct way. So for this use case particularly, replace is the way to go. So there are typically these are the two primary functions that you'll be using, replace and extract. So they are doing two opposite things, right? Extract is you just extract what you want and everything else is discarded. And in case of replace, you replace what you don't want. So what remains is finally what you desired in your column. Does that make sense? In fact, I was just doing that here. I didn't realize. Now I'm seeing the code. So okay. So apart from extract, there is an extract all, which returns every match. So now kind of going back to that question, but it is still creating, it returns a data frame. So there are multiple capture groups. So you can see that when I say I give uh, one another issue is that it will extract in exactly that order. So now what is it? This regex, what is it doing? Is that it's looking for a pattern where first there is a number, then question mark it handles that even if it is not present, it's fine, followed by alphabets and then followed by numbers. So in the first instance, wherever it found the number, then followed by some alphabets and then followed by number. Now, of course, here I can drop this column 1 and then I can join 0 and 2. But it's not a straightforward way. You would not want to do that. So just the player name, when we used extract earlier, we just said dot star underscore dot star. So when we extracted both the groups, we can also use extract all, because in that case there is no need of an expand argument, because extract all, it the whole idea is that you are capturing multiple groups. So it does that for you. So we are creating a first and the last name. Typically, I have not used people using extract all much. They just use extract and then they use expand argument, because it essentially is doing the same thing, right? There are multiple capture groups and then it is creating that many number of columns corresponding to the number of capture groups. So extract takes care of it as such. Is this clear? The string cleaning part? Yeah, I can just say thank you. I don't know what to say here. So I use regex a lot. In fact, for a very long time, um, my ID name for in my Stack Overflow flow profile was A to Z A to Z. So I really am fond of somehow I'm attached to regex for some reason. So I'm also trying to find though for string cleaning there is, I was just trying to see if there is an example that I can see where uh, it would be used. But there are many any kind of data that you work with, it could have there's always this chance of having gibberish, and then you need to clean. So that requirement comes in very often. If I If I come across some interesting example, I'll share the link with you all. So this is an actual example. Let me. I was just trying to search it up on my phone while. So somebody asked, of course, this was way back in 2012. So the actual data is like this, the result is having some characters. There's a plus and minus. Of course, uh, and there is also alphabet. The only thing that he's interested is in the number. So he doesn't want this plus minus sign and those alphabets. So then, of course, it's an old answer. So it's done using map, but I'm sure there would be a newer answer using. This is the answer written by Wes McKinney. But as I'm saying, this is an old. Okay, this is a new answer. So you can see str.extract backslash d plus. So you're simply extracting the number. So this is how you would go about it. And there are many such examples. So is there any doubt on the? Okay, there is one more example. Let me show you. So, okay, so the person is saying that the string is of this format. So there is a name, country name, and followed by space, and then in the bracket there is some characters. So, and what he wants is just the first part, the name of the state. So of course there are various ways of doing it. You can either say I just want to extract everything, just the first name before the space. I can say I want to replace everything which is after the space. So there are a couple of ways, both actually ideally it's just so this is using replace. So you extract the dot star till you encounter a space, and then this is another regex where you're saying that replace whenever you come across a space followed by something, just replace all of it, the space as well as everything following the space with an empty string. So what you would get is just the first name, right? So this is another example. I have I'll just show you one more example. Overall, the concept is clear. I'm just once again asking because this is something you'll be needing. Okay, just one example. Uh, a very classic example of how your text data could be. So this is just a pure string, but you could have it in a pandas column. So this is my string. It's an HTML, it has the HTML tag. So there is an HTML head, title, then the current IP check, title, head, body, current IP address. All that the person is interested in is this. So let me just copy it. This is an interesting example. Let me create a data frame out of it. I want all of you to try it. Do you have your Jupyter working, running? Oh, it's already time also. I didn't realize. Sorry. I'll just give you this code. This is my data frame. This is going to be your homework. Yes. This is your data frame. I want you to extract only the IP address from this column. So create a new column called IP. So as you can see, this string has the IP address. I want to extract that IP address and save it into a new column called IP. Will you all try that before we meet in the next session? And it's already time, so I will, when we start the next session, I'll start with a recap, and then, I'll quickly recap what we have covered, and then I'll move on with the new topics. But I want all of you to try this. I hope you saved, copied this code. Yeah. And I'm sorry, I mean, we are just overshooting on the time. There is somehow just, yes. So this is a feedback link. Please try to fill up because I'm still not getting from all of you the feedback because this is something which is captured across the organization, for all the trainers. It helps the company as well. So hope you all are with me on this. We have covered various things today. So I totally understand. I mean, do go through this document once again and we'll continue this session. I'll try to recap it in the next class. You can't find the class lab. Thank you, Deepak. Uh, anyone wants to help here? Let me give you the link, Jasmita. What happened? I'm sorry, I just have too many links open. Okay. Does anyone have the LMS link ready? It would be great. Which one are you talking about, Jasmita? See, this is the class lab. Do you see this one? The practice exercises. Try this link. That yes, this class lab, it does not. Okay, so I have not. Did I share the Python class lab with them? It looks like I forgot to. Okay. So the pure Python class lab I generated when with your batch. So I was creating along with your batch. I thought I shared with them, but looks like I haven't. But this is the Pandas class lab. So this has everything from, I'll show you the class lab one. What all does it have? Let me just show that to you. So class lab one. This class lab O.1 is the Python class lab one. Yes, this is the Pandas class lab. It starts from the iris, missing data, operations, time series, and it has some examples on the string methods. Not too many, just four. So this is an old file. So this all should be there in that. I haven't made any changes after that. Uh, Visualization class lab, you're saying, Uday? Yeah, thanks, Rana. Which one? The content for visualization. Visualization notebook is pretty old. There is nothing, no change. So you're saying there is no content in that file? This one. So visualization 7 and 8 is together. The content is the same file. See, if you see the file name also, my 9 and 10 is the same file, and 7 and 8 is the same file. It looks different. No, I don't think I have made much change. I might have added one or two. Uh, Let me just check if I see too many changes then. But I don't think I made many changes. So open. This is the 7 8. This is the simple plot. This is the one you're talking about, right? Uday? It's the same notebook. Sometimes I just add a cell to explain something and then I just delete it, most likely. I clean it up. See, when I'm adding, many times to explain something, I insert a cell. But that's not a clean notebook. So I usually delete it also, if you notice. I don't keep it. So area plot, Seaborn, it's exactly same content. There's nothing new. Facet grid, everything is there. Yeah, it's fine. Up to the heat map, just that. Yeah. The whole idea of the live session is that, many times it becomes easy for me to create an example in front of you and show it to you. But then I delete those cells. Okay, so you all have a nice weekend and I'll see you in the next class. Thank you so much. Bye bye.